we'll welcome Gavin along. Sorry we're overrunning a little bit, but you've got exactly the amount of time that you've requested for your talk. We promise you. You're ready to go, so with Godspeed,
Okay.
carry on, sir.
I hope
And we're going to shut up.
it's a Zoom team, whatever you want to call it. So the first thing has to be, can you hear me? I'm assuming you can, unless I get told otherwise. My name's Gavin Chester. I'm hoping that you can all see the screen and the magic is working. And this talks about micro red team testing. Kind of how many pen tests we're going to do a week. So let's click the right screen. So who am I? My name's Gavin Chester. I spent about 30 years, 32 in Big Pharma. 8 years making drugs. Sorry, penicillins, nothing interesting. 10 years lab support. So that was basically the machine had broke. Somebody has to fix it. New machines turn up. Got to make it work. 8 years as a data loss prevention analyst. So dealing with the people that just don't think what they're doing and accidentally let their company secrets out. 2.5 years as a red team analyst, which sounds really cool, but kind of the first year of that was we were starting out and setting up. So it was just things like a very boring authority to operate. Then it got to be a bit interesting. And last couple of years, I've been an information security officer. So I'm dealing with interfacing between the technical side of stuff and the business side of stuff, and hopefully getting to see eye to eye. So micro red teaming. This is not a lot of original work. It's a lot of what I found out about where we were going to go in the future, kind of a few bits of tricks and ideas, something that maybe you'll get an idea that you want to go forward with. Almost all of the code on here and examples is from either Red Canary's Atomic Red Team and the GitHub repositories there. Alternatively, it'll be using SRA's vector tool, which again, available on GitHub, freely usable, installing. I'm aware that in places this is going to look like an eye test. Please try not to read the screen, try not to read too much into it. So what's micro red teaming? Well, this isn't about doing a full-on red team test. There's just no point in doing that. It's not about pissing off the blue team with false positives. Well, sort of, really. No, it isn't. It's not about repeatedly pointing out the same issues to the blue team. Just talking a few moments ago in the pre-room saying, we've all got these issues that we know are never going to get fixed. There's no money to do it. It's an old system that we can't change. It's a system that we can't upgrade, anything like that. So the whole point of this is to find these issues, but if we found them again and again and again, there's no point beating that dead horse. But what it is about is just trying to speed up our analysis of risk exposure so we can look at what we've got out there. When we get a new actor, a new threat, we can see, well, could they get in? We've got all this protection in place, but does it protect the way that they're using and the way that their vector comes in? Try and give you an idea of where you're going. So if I just explain a bit more, a typical red team engagement, a pen test, it kind of looks at a system, a network, and invariably you've got to get something. So maybe they want you to get credit card data. So they say, well, we've put this flag file on your credit card server. Can you get to it? Alternatively, a pen test might be, can you break this app? They're all really good. They can take days and weeks, and they do find good findings. But invariably, you're going to find that one big issue. You've found the root of how you get to that file. That doesn't mean you've actually found all the vulnerabilities. If you're lucky, you patch those vulnerabilities, and you've kind of sort of stopped a bottleneck, so you've stopped everything. But that doesn't mean you really are sure that you've got all those. So what happens if we've got the ability to test everything all the time? And this is it's an impossible dream, but it's kind of where we went to. So this idea came from my manager at the time, and he saw it from somebody gave a talk at ArcticCon, Minnesota. I believe it was somebody from Target, but ArcticCon don't release their videos, so I couldn't go back and check it. And if you happen to be listening to this, I'm sorry I'm not name checking you, but I couldn't find who it was. But basically, can we red team the entire infrastructure on this semi-continuous and kind of regular basis? And that just seems like an impossible task. So where do we start? We start with a pretty simple core concept. We just take the red team down, put it into really small chunks, and we test them. So if you look at any of the MITRE techniques, you can see, can you get it to work? can you actually detect it in the sock? Do the sock notice? Do the sock care? Two different questions. We're going to do this at least once a week, random times, random days. Sometimes I'll do it in my ID. Sometimes it'll be a friend we've got somewhere else in the business. Sometimes it's going to be my machine. If it's something that potentially is going to trigger an alert higher up and somebody's going to get worried, it would be a computer that's obviously mine, or I'd give it a name of micro red team test. If it was something we really wanted to be sort of different and out there, I'd get a friend to run it on a lab computer, something that maybe a bad guy's got in, USB dropped in a car park, that sort of thing. If we track every time that we do these tests, we know when we started the test, we know when we finished the test, and we can find out when Blue actually got back to tell us, hey, was this you guys testing or was it not? So we're going to then sort of purple team, red and blue together, not really a proper purple team. We just had a meeting together at the end, try and see if there's anything that we can look, see, fix, and improve. So that sounds really obvious. He says changing his slides over, but you are going to be attacking your own enterprise, so you've got to have all the relevant approvals from your C-suite. You can start without that. That's probably going to be a little bit career suicide. Next thing is, despite what I said way at the top of the slides, this isn't about red and blue attacking each other in a lot of senses. You've got to work in partnership. You've got to trust what you're doing. I mean, the one thing that you don't want to do is start doing something right in the middle of an attack happening. So you've got to find a way that you can talk to each other, but you can still do the tests in secret. So as I say, you don't want to be launching a test when the SOC is already overloaded. You know, if they've got a real incident, you coming along with a little red test is not going to make them your friends. There is an argument that says that could be what the bad people are doing. They launch an attack over here, diversionary tactics, go and play something else somewhere else, and that's where they're going. But we're not trying to be a complete red team. We're trying not to be a complete simulation. So let's try and do it when they're not absolutely screaming and pulling their hair out. We don't want the SOC to filter out anything because it is a known user ID or a known device ID from people on the red team. So if it's my laptop that I'm using and I had my laptop and a test laptop, if they recognize it's mine, we just don't want them to go, well, it's Gavin, we'll not play with it, because sometimes it might not be. And similarly, we don't want the red team, the SOC to look at it and go, that's a really pointless little test. That's just a micro red team. Again, you've got no guarantee it really is. Chances are it is, might not be. So where do we start with this? The good thing is you're not at zero. There's lots of attack tools out there. They've got this new category, breach attack simulation tools. There's an awful lot of them out there. We went with Red Canary's Atomic Red. There is Endgame's Automation, Kalida from MITRE, and Uber have a tool called Meta. They're all really good, but the reason why we started using the Atomic Red bit is it's really basic. It's nothing more than a set of scripts on GitHub. So the beauty of that is you have to spend a bit of time working on it, but then you can just pick up that script, take it to a machine, go and run it anywhere. If you've got the ability to copy things to USB, write them in there. You can copy on a USB, go to where you're going, install that script, run it in command, run it in PowerShell, whatever you happen to be needing for it. The only downside to that is that there isn't any embedded reporting in Atomic Red, and that's why we started using Vector. So we have to do a test, log where we're doing, kind of report it ourselves. I'm sure that everyone is familiar with the MITRE attack framework. This is where it gets to be an eye test, and no, I'm not expecting you to read any of that. But we all know that there's this long framework, but we can start off with a few bits and pieces that we know there's no point working on. First couple of steps on the left-hand side, the reconnaissance and the initial access. There's a lot of benefit if you can stop somebody in that phase. If you've got somebody who's searching for your whales, your users on social media, if you can stop them, brilliant. But you know what? We probably can't. If there's an awful lot of active scanning on your perimeter, well, chances are you're being scanned. Yeah, welcome to the internet. That's business as usual. We already do phishing simulations on our users. If we're going to do phishing simulations as part of this red team, we're going to probably cause problems. We're either going to pollute the work that they're doing, so they're going to think, well, that was better or worse than what we've been doing. What we're going to do with it? Are we going to break some of these things? Are we going to send it to the wrong place? And we could potentially do stuff that is all publicly facing, so it's a drive-by. It's just about practical. But in real terms, it's not practical for this sort of test. And it's even dangerous. We want to do this in a very tight, controlled manner so we know when we've done it, what we've done it with, who we've done it with, when the detection is. If you've done something that's a public drive-by, even if it's a private drive-by sort of in your internal sites, you don't know when that test is going to happen. You've got no idea what's going to do it. It could be one person picks it up, 5 people, haven't got a clue. So we tended to stay away from the reconnaissance and the initial accessing. So basically, we're going to assume that us as the bad guy has got in, and we're going to kind of concentrate on the whole bundle of the MITRE chain. So I'm going to move on to a couple of examples. So the first one is going to be privilege escalation. The way that it works is pretty simple. Go to MITRE, the Red Canary Atomic Red database. They've got a wiki page about it, and you'll get this choose a test. Now they're all sorted by their T number, but you can also have them. You see just down at the bottom, we've got all tests. We've got Windows, Mac, and Unix. We tended to use Microsoft stuff because that's what we got most of the time. I had a laptop that I dual booted to either Linux or Windows, depending on what I wanted. We didn't have many Macs in our environment at the time, so we didn't purposely choose not to use Macs, but we knew that it was a much lower attack surface, and while we can use it now and again, let's concentrate on the low-hanging fruit, the stuff we really can get. But just remember, you are almost certainly going to have these oddballs in your environment, so you're going to have some.
All right.
Macs.
Hello.
Hello.
Okay.
The Zoom just completely shut itself.
My end or yours?
Okay.
Yeah, we're just looking at it coming back. It's cartwheeling.
Yep. We lost Zoom there, folks. So we're just getting Zoom back and hopefully Gavin back.
Yeah.
And hopefully he's not just speaking into the void.
I don't think so. It looks like he stopped now.
Oh, no. Gavin's there.
Yeah, just
We just can't see it. It's going out on stream.
Okay, great.
So if you say Gavin, continue, because they can see it, that's our problem.
Yep. Gavin, carry on as you were, sir. The stream is working fine. We've not got you in the studio, so carry on. Thank you.
You've just put me off my flow. My flow. Thank you. Anyway, so you're always going to have those oddballs. There's always going to be somebody that's got something or other. As I said, I worked in a lab environment. We always had a few weird and wonderful bits that would only run on Unix. You've probably got a graphics department that, for all sorts of weird reasons, they won't use PCs and insist that Macs are the only thing you've got. So you're going to have those in your environment. Don't forget to test for them. They might be there. So looking at a couple of examples, as I said, we'll start with privilege escalation. So the tests are actually pretty simple. You can see we've got 1078 here, just setting up some local accounts. All the different T-tests have got different number of subtests. This particular one has got one. The Red Canary Atomic Red gives you the instructions, and you'll note that it needs to be admin, so I've just got a screenshot there. I'm pretty sure you can all read what we're doing. We're going to add a user, we're going to set the user's password, we're then going to push that user into the local administrators group. And nicely, even gives you the cleanup commands. So I think most of us would probably be really surprised if we could actually detect that. I don't think there's many companies that would probably detect a local account being set up on a local machine. Adding somebody into a domain, putting a domain user into a domain group, yeah, we've probably got some detections for that. They may work, they may not, but would we ever do it on the local machine? Not sure. If you do have that login that goes into a SIM, what are your rules? How would you surface up that one single event when you've got thousands, tens of thousands, hundreds of thousands of endpoints? And would that actually even be a priority? A local user suddenly being created on a machine? No, not sure. Another example, persistence. So this is 1547. This has got 7 different tests. So you can see we're adding a couple of things to registry keys, trying to get stuff into the startup folder, the user startup folder. So we've got a suspicious, in this case, it says Visual Basic JavaScript or a batch file, but it could be anything, just any file you want. We're adding it to the startup, or we're adding it to the run once. So when the user logs in or when the machine starts up, it goes off and does something. If we were bad guys with an implant, maybe we're getting that implant to start up every time. I know that this is not really, really complex in terms of sort of operational stealth and things like that. It's not meant to be. It's meant to be a test. One thing to remember is that the the known malware, as I'm calling it, the in this case it's the hash command to execute part, isn't necessarily going to be malware. It could be a batch file that's going to keep re-adding your users. It could be an implant. If you've really done it well and you've got your Cobalt Strike and you've encrypted it and you've got your private keys and nobody's leaked those keys and things like that, maybe you're going to get a file that will not be picked up by a signature-based IV. Maybe it will, maybe not. Different AVs work different ways. But ultimately, you've got to remember that that file isn't malicious in itself. The maliciousness is the adding the persistence. He says, turning this files over. So kind of like the first one, are we ever going to see that that's been done? I mean, if you think about it, this is what software does all the time. The software comes along, sets itself up, puts its drivers in, puts its little tray icon in, does its setup to start automatically when the user logs in. All of this is standard. This is normal industry practice. We're not doing anything strange. So would we ever see it? Software, we rely on the antivirus to check that the file's not malicious, but we're kind of not missing the non-malicious files that could be malicious. And again, I don't think SOCs are ever going to detect this in the noise. And yeah, I know what you're probably thinking. I'm being really bad on the SOC. So we're looking for a local alert on a machine that's potentially in amongst thousands. So let's try something a bit noisier. So my third example is C2 exfiltration using DNS 1071. There's 4 parts to this test: sending a large volume of DNS queries, beaconing out on a regular interval, pushing out a very long domain query, and a simulated C2. I'm not going to give you all the commands. I think we've got the idea by now. But we've all got this wonderful next-gen hardware that can see all and do all, and it's going to surface these. It's going to tell us, and within minutes, it's going to maybe even block it. Well, we'll see. Something to note on this one is because it's DNS, it needs a digital. Well, I use the DigitalOcean DigitalOcean droplet, but we're needing an external destination of some description. The reason why I went with DigitalOcean is they're kind of cheap, $5 for a small droplet. I could spin it up, have it running, delete it, and wipe it. Probably cost less than $1 a week, if that to use. It's $5 a month. I could put them anywhere that DigitalOcean had got a data center. I tended to use Singapore and Bangalore because we don't have a lot of company infrastructure there. It's not trying to hide it completely. This should kind of trigger some alerts of why is our DNS going to Singapore? Just trying to make it stand out a little bit more. As I said, droplets were cheap. So it's going to be probably apparent from these names, but they all use DNS. So the first one sends out a lot of DNS queries to a specific IP in a short time frame. Not normal DNS behavior. Second one does the same thing, but instead of it being a lot in a short time frame, it's just sending them out on a regular pulse. Test 3 shoves the DNS up to as long as it can be, which I think is 254 characters. And again, unusual. It would be really unfair for me to use a test that sent that one query out. I don't think there's anything that's next gen that's ever going to catch anything that simple, because if it's never seen it before, it can't make a judgment. And if it never happens again, well, it doesn't know about it. So to be fair to the blue team, I put this in a loop, so there was quite a few of these calls being doing. And the fourth test uses DNS cat to try and simulate C2 activity between them. So, as I said, surely all this wonderful next-gen kit caught it. Yeah, no. And if you think about it, we kind of got a lot of the systems that we use. I've got examples there, AV and cloud, work on virtual cloud instances, and they've got these long names, the very things that we almost looking to try and pick up. So I've got an example there that's an Amazon reference. So each C2 is your size, and then yes, okay, I picked random numbers. That's not really an IP address, which is what the next set digits should be. Location and details about it. And at this point, you're probably thinking, what am I talking about? So just to bring this home, this is actually very real world. So you've got a query there with these 70 FOV, all the rest of it, was actually the query issued by the Sunburst malware to tell the C2 server that it implanted itself on a Cisco machine. So the 70 FOV was saying this is cisco.com in whatever way they've encoded it, and you've got the rest of the strings. But that query looks awfully lot like an Amazon address. And I do not doubt that that is extremely deliberate on the part of the bad guys. So we've got all our tests. We take each test. We've got yeses, nos, detections, things like that. Log them into Vector, and we can try and visualize this. So we can try and understand what the technique the actor uses, how they're going to look at it on our defenses, and kind of repeat it, see if you go in. So I've got a few screenshots just showing you that. So the APT groups, you can see we're bringing them all in here. These are all the reference screens that come from SRA. I'm not giving you any company data away. You see we can drill down and look in any particular one. We've got APT33, so there's the things that they were known to use. We can also build a custom campaign. So if we had intelligence that APT33 were thinking of attacking us, we could bring one of these custom campaigns in, look at it, and then we can maybe look at it, either run the campaign ourselves, so we can go, let's not micro red team this, but we'll just run through all of these and see where we go. Alternatively, we can kind of look at that, look back at our heat map, and try and work out if we're going to be attackable or not. So, as I said, we get a heat map. So, should be kind of obvious. Red is bad, green is good. You can see just looking there, in the example data that we've got a boot or log on auto start execution, which is kind of green, which probably means you've got good detection about it. So my tests earlier should have been picked up. Then you've got some things that are yellow and orange where there's minimal coverage. You can also see that when you drill down into the tests, if you do them often enough, you've got an idea of where you've got better. There's two examples there. One's the green outlines, one's the red. You can see how the first time the LMNNR test was done, went through the second time. Third time it was blocked. Interesting, there's no alert triggered, so probably that's something being done by the scenes rather than the SOC being said, hey, we need to go and look at it. And you can see the other one for yourself. And I'll move on. Okay. So in theory, every one of these tests could have been caught. You know, if you'd logged enough, if you'd then looked through those logs hard enough, you would have found them, absolutely without a doubt. But, you know, the SOC analysts rely on automated tools. We're not trying to burn the SOC analysts out. Well, you know, you can't do that. But the question is do we actually know where these things are working? So in my examples, they're all a local, well, most of them are a local alert. The DNS one would have been on your, maybe your firewalls or your proxy logs. They would have alerted. They would have alerted locally. They would have written into the log. Did that log get to the SOC? Did it even get into the SIM? And that's where we started looking at this. So we'd look at our purple team debrief. The SOC would look at what we'd done. We'd talk about it. Sometimes they caught us, sometimes they didn't. It was usually about 50-50. And if there was anything where they went, where we should have picked that up, why did we not pick that up? The beauty of this is we knew exactly where and when we'd done it. We knew the machine name, the time, all that sort of thing. Go back into the audit trails, go back into the SIM, go into the SOC alerts, and you can try and work out where that alert somewhere got triaged out. So how did this all work out for us in practice? Yeah, this is where it goes wrong. So we ran these tests for about 9 months. As I said, 1 or 2 a week, random times, random dates. So it wasn't always Monday morning, and they could be spread through the week. Usually when I'd got an extra half an hour, I could just slot one in. So we were just trying to build up this nice heat map, what we've got, where there were holes. And at that point, my employer decided that we didn't need an internal red team anymore. So we were all made redundant, and I moved sideways into my current role. So yes, this 9-month project never really made any impact in the grand scheme of things. But the key takeaways. So micro red teaming is a mouthful, so it needs a better name. Defense engineering, I know it's been mentioned in other places. It does sum up what we're trying to do. We've spent all this money on next gen hardware, next gen X, Y, Z. It doesn't matter what it is, but I'm sure it's next gen. We spend all the time getting those systems up, running, and installed. And then do we actually go back and check that we're getting the alerts that we think we're getting? So I said we try not to burn the analysts out. So we tune things out, but do we tune too far and too much? Do we ever re-baseline our tools as often as we could? So if you think back to my the SolarWinds thing, they wrote that so that the DNS string looked very much like an Amazon string. You know, if you've said, well, if it looks this long and it's got so many bits, you've got some clever regex that makes it look for US East, US West, it's entirely possible that you've actually just managed to triage out the alert that you were looking to detect. And finally, do we have that right coverage? Some systems are forever stuck in learning mode. We do use Carbon Black. I'm aware of a couple of systems that every time they move them off at learning mode, something breaks, they put them back in learning mode. So the cost of that agent, and they're not cheap, is actually wasted. It's not doing anything. We're not getting any alerts sent back for it. I'm sure we can do things better. So what started off as a way to test our defenses kind of just changed as it went along. It didn't work out for us, my current company, but it could work out in yours. My ex-Red Team manager is doing this same thing in his new role, and he's always found bits where they've got to it and gone, hey, we should have got an alert from that. Why didn't we? And it's warranted further investigation into working out why or when or why something didn't happen. So, as I said, the real key takeaway, the one thing if you do it is, other than somebody's time and effort, there isn't any major cost to trying this process out. All the software's free. Yes, you've got somebody's time. You need to spin up a couple of DNSs. If you get a little more complicated going down the line, you probably need some domain names. It's peanuts. It really is. You know, all the time that we did all these tests, we probably never spent more than £100 on them. So what have you got to lose if you want to try this out? And what visibility might you actually gain into how your systems might be at risk? And that's it. I just have a couple of thank yous. Firstly, to all the people in Red Canary and SRA who made they've got the tools out there that gave them away, made life a lot easier. The people that actually contributed to all those Red Team tests, I don't think I could have sit and written the scripts myself. In fact, I know I couldn't. But because somebody's done it, it's easy to pick them up, go and use them, pick them off the shelf. And thankfully to whoever gave that talk at Octocon all that years ago, that put the idea in my manager's head and got me to go and run with it. Last couple of things. Chris B, Chris M, my two Red Team colleagues who we had a lot of fun in 2.5 years. I think one of them may be listening in, I'm not sure. If he is, hello. It did take me a huge amount in that short time we were active. It was really interesting. And also to our blue team, and again, I think there's might be one of our ex-blue team listening in. Hello. They took it entirely in the right way. They didn't see it as Red Team just being trouble, Red Team looking to just create a problem, find a problem and keep saying, you've not fixed it, you've not fixed it. It was definitely a learning experience for us both to go back, understand what could work, understand what couldn't work, and ultimately how we could defend the company better. And that's it. If I haven't talked too much and hit the time limit, I'm happy to take questions. There is my Twitter handle there. It's GJC, but there are 2 underscores because somebody else had stole it. But I don't know whether I'm at time.
You run perfectly to time, but we are running over time.
No problem.
But that's absolutely fine. So, Gavin, thank you very much indeed. Another great talk, great feedback. Thanks for joining us. Cheers.
Hey, bye.
Brilliant.
Thanks, Gavin.